Hello everyone, my name is Vanshu. I am from BSc Chemistry Honors second year. This is an audio lecture for visually impaired students from the book S. Chand of the chapter Diazonium Salt. Question number 1. What are diazonium salt? Give their nomenclature. Diazonium salt are aromatic organic compound containing N2X group where X is a halogen. It could also be a NO2, HSO4 or BF4 group. The name diazo stands for a nitrogen. The word onium is obtained from ammonium as this compound resembles ammonium salt in some respects. Nomenclature. Diazonium salt are named by adding diazonium to the aromatic compound to which it is attached, followed by the name of the anion. Names of some diazonium salt are given below. Benzene diazonium chloride, benzene diazonium hydrogen sulfate, para-toluene, benzene diazonium bromide, para-nitrobenzene diazonium fluoroborate. Question number 2. Discuss the structure of benzene diazonium chloride. Number 1. Answer. It has the molecular formula C6H5N2Cl as confirmed by the qualitative and quantitative analysis. It is colorless crystalline solid soluble in water but insoluble in alcohol and ether. Number 3. It undergoes substitution reaction in which N2Cl group is replaced by a movement of group like Cl, Pr, Cn or NO2 group. Number 4. Benzene diazonium chloride exhibit salt-like character. This is indicated by conductivity measurement. Number 5. It gives coupling reaction with phenols and amines to form azo compounds of the type N double bond NNH2. On the reduction with stannous chloride and hydrochloric acid, it gives phenyldrazine. Number 7. It forms salt called diazoate in alkaline solution which exist as geometrical isomers. 64. Based on the above observation, different scientists have their structure for benzene diazonium chloride which are represented below. Greece formula. Greece was the discoverer of benzene diazonium chloride. He proposed the following structure of the compound. However, this formula was not constituent the properties of the compound. It did not explain well the following properties. Number A is its salt-like character. B. Replacement of N2Cl by other monovalent group. Reduction of phenyldrazine in which one nitrogen is attached to the benzene ring. D. Formation of azo compound in coupling reactions. Calcule structure. Calcule gave its structure of benzene diazonium chloride as other. This formula explains satisfactorily replacement of N2Cl by monovalent group, coupling reactions and reductions to phenyldrazine, but it didn't account for the salt-like or ionic nature of the compound. Bloom-Strand formula. Bloom-Strand gave the following structure of benzene diazonium chloride, but this has been modified to this modified resembles that ammonium chloride can give chloride which can be written as this structure well. A salt-like or ionic structure of the following compound is as indicated by conductivity measurement. B. Solubility in water and insolubility in organic solvent. It is common observation that polar compounds are all soluble in poor solvent. C. Presence of nitrogen triple bond as indicated by infrared spectrum. D. Existence of geometrical isomer of diazoates. C6H5N positive triple bond NCl in presence of NaOH changes into C6H5N positive triple bond NaOH negative. Benzene diazonium hydroxide. Soda benzoate C6H5N double bond NO negative Na positive. Due to the presence of double bond between nitrogen and nitrogen, there exists a possibility of occurrence of geometrical isomer as given below. Question 3. What is diazotization? How is benzene diazonium chloride prepared in the laboratory? Give its mechanism. Diazonium salts are prepared by the reaction between aromatic primary amine and nitrous acid obtained from sodium nitrite and dilute hydrochloric acid in situ. For preparing benzene diazonium chloride, the following method is adopted. Aniline is dissolved in dilute hydrochloric acid and the solution is cooled to 273 to 278 Kelvin. Now a cooled solution of sodium nitrite is added to the first solution, taking care that temperature does not rise beyond 278 Kelvin. A few drops of the mixture are added to a starch potassium iodide solution. As soon as blue color is obtained, further addition of sodium nitrite is stopped. Thus, the exchange of nitrous acid is avoided. This is the completion of diazotization. C6H5NH2 plus NaNO2 plus HCl changes into 273 to 278 Kelvin. C6H5N2 positive Cl negative plus NaCl plus 2H2O. Benzene diazonium chloride obtained above is used as such in the solution. It is not extracted or crystallizes out. This is because dry benzene diazonium chloride is explosive. Mechanism of diazotization. It is believed that the amine molecule undergoes nucleophilic reaction by attaching itself to nitrous anhydride obtained from nitrous acid. The complete mechanism is given below. Aromatic amines carrying electron withdrawing group in the benzene ring are difficult to diazotize. This is because mechanically it is a nucleophilic reaction. Electron withdrawing group decrease the electron density on amino nitrogen, thereby reducing the chances of attack on nitrous acid and nitrous anhydride. Question number 4. A. Give the synthesis and mechanism of diazotization. B. Which of the following gives most stable diazo compound on treatment with HNO2 and why? C. 2H5NH2 aniline orthonitroaniline. Answer question A for synthesis and mechanism. Question number 3. B. Aniline gives the most stable diazo compound via benzene diazonium chloride on treatment with HNO2. Aliphatic amines don't give diazo compound. Alcohol is formed on treatment with HNO2. Extent of diazotization is decreased if an electron withdrawing group like NO2 group is attached to the benzene ring. Question number 5. Describe with mechanism wherever applicable chemical properties of benzene diazonium chloride. Properties of benzene diazonium chloride can be discussed under two heads. A. Reduction in which N2 is evolved and the N2Cl group is replaced by other monovalent groups. B. Coupling reaction of reduction in which nitrogen atoms are obtained. These reactions are being given separately as under reactions in which N2Cl is replaced by some other group. Number 1. Replacement by chlorine, bromine or cyano group. This is a reaction in which group is replaced by one of above mentioned group. The reaction is carried out by treating a solution of diazonium salt with cuprous chloride, bromide or cyanide. The reactions are given as under. This reaction is known as Sandmeyer reaction. In slightly different reaction known as Gattermann reaction, replacement by Cl, bromine or cyano is done by taking copper powder and halogen acid, such as benzene diazonium chloride. In the presence of copper and HCl changes into chlorobenzene plus N2. Number second, replacement by iodine ion. On warming, diazonium salt solution with potassium iodine solution, N2Cl group is replaced by minus I group, C6H5N2 positive Cl negative benzene diazonium chloride plus potassium iodide changes into benzene iodide, yeah, or iodobenzene plus N2 plus KCl. Number 3. Replacement by fluorine. Replacement by fluorine can be brought about by the following two steps. Benzene diazonium chloride plus H-fluoroboric acid changes into diazonium fluoroborate plus HCl. Number 4. Replacement by OH. On warming, the solution of diazonium salt N2Cl group is replaced by OH group to yield phenol. Benzene diazonium chloride plus H2O changes into phenol plus N2 plus HCl. Number 5. Replacement by NO2 substituent. Substitution by nitro group is achieved by decomposing diazonium fluoroborate with sodium nitrite solution in the presence of copper powder. Replacement by aryl group. Benzene salt react with other aromatic compound in the presence of alkali to give diphenyl. Number 7. Replacement by hydrogen. If diazonium salt solution is allowed to stand in contact with hy- hypophosphorus acid in the presence of cuprous ions, N2Cl group is replaced by H, C6H5N2Cl plus H3PO2 plus H2O, C6H6 plus H3PO3 plus N2 plus HCl. Mechanism of the reaction is as follows. Aromatic N positive triple bond N plus Cu positive cuprous changes into Cu2 positive Ar and triple bond N plus Cu2 positive Ar plus N2. Reactions in which nitrogen atoms are retained in the product. Number 8. Reduction. On treatment with stannous chloride and HCl, diazonium salt are reduced to hydrogens. Question 6. What is coupling reaction? Give the mechanism of coupling reactions with phenol and tertiary amines. Answer. Coupling reaction. It is an important reaction of diazonium salt and involves reaction of diazonium ions which act as electrophile agent with aromatic compound containing strong electron releasing groups such as OH, NHR and NHR2. The reaction is known as coupling and lead to the formation of azo compounds having the formula C6H5 N double bond N with benzene ring into G, where G is one of the mentioned electron releasing group. The coupling reaction it generally may be written as given under. A. Coupling reaction with phenol. Benzene diazonium salt react with phenol in weakly alkaline solution to form hydroxyazo compound N2 positive Cl negative plus phenol at in the pH range from 9 to 10. Para-hydroxybenzene is formed. Mechanism of the reaction it involves the electrophilic attack of diazonium ion on the phenoxide ion as shown below. Coupling reaction with tertiary amine. The coupling reaction takes place in acidic solution. Diazonium salt reacts with tertiary amine to form dialkyl aminoazo compound. The mechanism of the reaction is given as follows. Question number 7. How are diazo salt prepared? Compare the stability of aliphatic and aromatic diazo compounds for and give their synthetic applications. For preparation of diazo salt. Question number C. Question 3. For synthetic applications. See question 5 and question 6. How does benzene diazonium chloride react with aniline in mildly acidic medium? Give the mechanism of this reaction. Primary and secondary amines react with diazonium salt in weakly alkaline medium to form colorless diazoamino compounds. However, these compounds undergo rearrangement when heated in acidic medium to form colored azo compound. Mechanism of the reaction is given below. How will you synthesize A. Orthotoluic acid from toluene. B. Metabromophenol from nitrobenzene. C. 1,3,5-tribromobenzene from aniline. D. Ortho and para-dinitrobenzene from aniline. Answer of A. Orthotoluic acid from toluene is as formed. Toluene reacts with HNO3 in the presence of H2SO4 changes into O-nitrotoluene. Then reduction occurs in the presence of CnCl2 HCl. Then orthotoluidine is formed. Further, it reacts with NaNO2 and HCl to form orthotoluene diazonium chloride and CuCN with reaction gives CH3CnH2O or further with reaction with H2O, or we can say by hydrolysis O-tolvic acid is formed. Similarly, these above reactions are given to produce ortho and para dinitrobenzene from aniline. How will you Question number 10. How will you bring about the following conversions? Para-nitroaniline into 3,4,5 triiodonitrobenzene. Para-toluidine into metabromotoluene. C. Nitrobenzene into bromobenzonitrile. D. M-dinitrobenzene into meta-nitrochlorobenzene. Answer: all reactions are given for this question. Answer number A. Para-nitroaniline reaction with iodine in the presence of ferrous changes into 3,5-diiodo-4-amino-nitrobenzene, which further reaction with NaNO2 and HCl give, gives this product, and then with further reaction with potassium iodide gives 3,4,5 triiodonitrobenzene. P. Toluidine into metabromotoluene. P-toluidine reaction with CH2CO twice into O gives paramethyl acetylenitrate, with reaction with bromine gives this compound, and with hydrolysis it will gives this, and with then reaction with NaNO2 HCl this is formed, and after that with reaction of H3PO2 metabromotoluene is formed. Question number 11. Explain the following. During the diazotization of aryl amines, excess of mineral acid is used. Answer is to avoid coupling reaction due to formation of aryl NH3 positive, excess mineral acid is used. Number second, a weakly basic solution fears coupling reaction with phenol. High acidity suppresses the formation of the more reactive C6H5O negative. In the presence of weak base, C6H5O negative is formed out, but C6H5N double bond N positive OH is not formed. Number third, 2,6 dimethyl nitrogen dimethyl N-dimethyl has a free para position, but it does not undergo coupling with benzene diazonium chloride due to steric hindrance of methyl groups. The para position of 2,6-dimethyl and N-dimethyl is not sufficiently activated for coupling reaction. Question number 12. Starting with benzene, outline synthesis of the following compound using diazonium salt H intermediates: para-hydroxybenzene, phenylhydrazine, phenol, bromobenzene. Answer number 1. First conversion of benzene into benzene diazonium chloride. Diazomethane. Question 13. Give the structure, method of preparation and synthetic usage of diazomethane. Structure: it exists as a resonance hybrid of two structures given. Method of preparation: it can be obtained from N-nitroso and methyl compound as shown below. Second, by passing nitrous oxide N2O through an ethereal solution of methyl lithium CH3Li. Properties of diazomethane: action of heat. When heated or exposed to light, it decomposes to form methylene, CH2 double bond N positive double bond N negative, Tl or H mu CH2 methylene plus N2. Methylene is very reactive and adds to alkane to form higher homologous CH3CH3 plus CH2 changes into CH3CH3C, CH3CH2CH3 propane. Second is reduction. On treatment with NaHC, it gives methyl hydrazine. Third is reaction with mineral acid. When it gives the following compound. Reaction with carboxylic acid. Diazomethane react with acid to form methyl esters. Reaction with phenol. On treatment with diazomethane, phenols get methylated. Reaction with alcohols and amines. Hydrogen of the alcohol or amine is replaced by methyl group in the presence of PF3. Reaction with carbonyl compound. Diazomethane convert aldehyde into ketones with while ketones are converted into higher homologous. 8. Ring expansion. Cyclohexanone react with diazomethane to produce cycloheptanone. 9. This method is used to produce the higher homology of a carboxylic acid by the following sequence of the reactions. Complete the following reactions as given. Question number 15. Starting from benzene diazonium chloride, how you get the following compound: ethanol, nitrobenzene, C6H5 N double bond NNHO. For above, see question number above. Explain why this reaction is carried out in weakly alkaline medium. Reaction is uh, ben- benzene diazonium chloride plus phenol, weakly alkaline medium. Weakly alkaline medium helps in the removal of protein in the intermediate step of the reaction. What are Sandmeyer reactions? Reactions in which N2Cl group of benzene chloride is replaced by chlorine bromine or cyano group is called Sandmeyer reaction. Question 18. How will you synthesize the benzylamine from aniline? The synthesis involves the following step as given in the form of reactions. Thank you.